In addition, there are some important properties of conditional probability. The first one is that the probability of phi and psi is equal to the probability of phi times the probability of psi given phi. And this is relatively straightforward to see just using the ratio formula. So the probability of psi given phi is equal to the probability of psi and phi divided by the probability of phi. So if we were to multiply both sides of this equation by the probability of phi, multiply this side by probability of phi as well, notice the probability of phi will cancel with the denominator, the probability of phi, and you end up with the probability of psi and phi, which is of course the same as the probability of phi and psi. So we get the probability of phi and psi, which is equal to the probability of psi and phi, equal to the probability of phi times the probability of psi given phi. And this can be generalized by taking the conditional probability with respect to chi. So here, the probability of phi and psi given chi, the probability of phi and psi given chi is equal to the probability of phi and psi and chi divided by the probability of chi. So this is the left-hand side of the equation. What about the right-hand side of the equation? Well, the probability of phi given chi times the probability of psi given phi and chi is going to be equal to, so just apply the ratio formula to both of these conditional probabilities. It's the probability of phi and chi divided by the probability of chi times the probability of psi and phi and chi divided by the probability of phi and chi. Now we can simplify the multiplication of these two fractions. So the probability of phi and chi cancels with the probability of phi and chi. And now we get the probability of psi and phi and chi divided by the probability of chi. But of course, this fraction here is equal to that fraction. Those two are the same. These two numbers are the same. So we get the probability of phi and psi given chi is equal to the probability of phi given chi times the probability of psi given phi and chi. One final property, and this is a very important property, this is sometimes called the law of total probability, is that we can think of the probability of phi as being a weighted average of the probability of psi times the probability of phi given psi, plus the probability of not psi times the probability of phi given not psi. So in a picture, if we were to draw phi, so here's phi, and we have some other formula psi, so here's some other formula psi. Well, phi and not psi is this red region right here, and the blue region is going to be the phi and psi region. And we know, given a previous formula, is that the probability of phi is equal to the probability of phi and psi plus the probability of phi and not psi. So the probability of this phi region is the probability of the red region plus the probability of the blue region. So we see that the probability of phi can be written this way. Well, what about this equation right here? Well, the probability of psi times the probability of phi given psi is going to be equal to the probability of psi times the probability of phi and psi divided by the probability of psi. And the probability of not psi is going to be times the probability of So this is the probability of not psi times the probability of phi given not psi is going to be equal to the probability of not psi times the probability of phi and not psi divided by the probability of not psi. Now, again, we're going to see that in this first equation right here, the probability of phi's cancel and the probabilities of not psi's cancel. So if I were to add these two numbers, I'm just going to get the probability of phi plus the probability of phi and not psi. So these two numbers are going to be the same. So the probability of phi is equal to the sum of those two numbers. And we get that the probability of phi is equal to the probability of psi times the probability of phi given psi plus the probability of not psi times the probability of phi given not psi. And this is a very important property that you'll use from time to time.